Hey all, good afternoon and welcome to another session with me, Varun at OdinSchool. And in this session, the topic would be to understand what is model tuning and how do we use grid search CSV, or how do we use grid CSV as we call it. Okay, now what are these words, that is model tuning and grid search, and where and how and why do we use them, would be the agenda of this session. And for all those of you who have come onto this platform for the first time, guys, we all know what machine learning is and how important it is. Machine learning is a very important branch of AI, that is artificial intelligence, and is directly connected to great technologies like IoT, or probably deep learning or machine learning, and etc. And as we all know, this technology happens to be the hot cake of 20th century, which gives us a good reason to learn machine learning. And we at OdinSchool, we are a technology upskilling platform, and we would help you continuously acquire new skills. Thereby, you could stay skilled and stay ahead. And my name is Varun. I come with an experience of 7 years wherein I've been working predominantly as a developer and passionately as a trainer as well, right? And over these years, I've been able to work on different languages, and I've been able to, gain knowledge on different languages like HTML, CSS, JavaScript, R, Python, machine learning, and technologies which include machine learning, deep learning, etc. Right? So now, keeping this in mind, let us move ahead with the session, or with the core topic of interest. That would be to understand what is model tuning and what is grid search CSV. So firstly, we would be understanding a theoretical part of it, and then it would be followed by a small coding example. Right, guys? So this is what we have here. So now let us go ahead with this. Right, so now when we talk about model tuning, or when we even come across this word, that is model tuning, this word catches a lot of attention, or this word somehow ensures that there's a lot of people who think a lot about what model tuning is, and do they have to learn a lot of code, or is this a new concept and all. Guys, model tuning is basically like adjusting the antenna of your TV, like as you can see here, just so that you have good signal. So it is the process of maximizing a model's performance without overfitting or without underfitting or without having too much of variance. So here the only thing that we are doing is coming up with a good model. And there are many ways to come up with a good model, as we know. I mean, there is no, there is no hard and fast rule, or there is no only one end procedure where this is the only way that you can tune your model. There are a lot of ways, and it is often easier to improve the data that we feed in the models than to fine tune the parameter of the model. So what we are trying to understand here is, it is easy to improve the data. That means the data which is coming from the backend can be improved as compared to fine tuning the parameters, right? But assuming that your data is already clean, okay, or your data is already done with its job of cleaning and removing all those which are not required, adjusting, transposing, transforming, all this is set and done. Now what? Now in this case, we would want to improve the accuracy of your forecasting model. Then we have to enrich the data in the feature set firstly, right? So this is where hyperparameters come into picture. Now, when we talk about hyperparameters, choosing a correct set of hyperparameters is very important for model accuracy. But hyperparameters are also challenging, because hyperparameters are things which we have within the bracket. For example, when I use decision trees, and within brackets I have minimum tree depth, maximum tree depth, or minimum sample leaf. Now, when you have things like these are called properties or hyperparameters. Right? So choosing a correct set of hyperparameters is very, very important as far as um model tuning is concerned. Okay. Now, as you can also see here, hyperparameters are different from other model parameters in that They are not learned by the model automatically through training methods. Instead, these parameters must be set manually. Right, guys? So here we try to ensure, or we rather ensure, that these models are set apt, or they must be set manually. Okay. Now there are different methods for selecting hyperparameters. The first one being grid search, the second one being random search, and the third one being Bayesian optimization. Right, guys. So the most important are grid search and random search. And we would be looking at grid search in depth because that happens to be a very, very important hyperparameter for us as a beginner, or even probably as an experienced, or as a person who's trying to master deep learning, or machine learning. Rather, even for machine learning, I would say grid CSV or grid search CSV is a very, very important parameter. So now we'll talk about it. So here, as you can see, grid search is also called as parameter sweeping, and is one of the most basic and traditional methods of hyperparametric optimization. So here, now let us start talking about grid search for a while. Or rather, let us start talking about hyperparameters. Hyperparameters. Let us just talk about them for a while. Now, we all know that we have two variants. The first one being model parameters, correct? And the second one being hyper. Now, what is the difference between them should be your first question. Now, model parameters basically they take care of training the whole algorithm. Okay, so rule number one, they are for whole algorithm or entire algorithm. Right, guys, that is the first point. Now, while an algorithm learns what we call as the model parameters, okay, from the data, we use, okay, these, I mean, the model parameters, they use hyperparameters, okay, and they use hyperparameters to kind of stimulate the behavior. All right, guys, or to power it up. Now, let us just understand the very fine line of difference between hyperparameters and model parameters. So, model parameters, when we talk about it, you have moreover things like weight or coefficients, okay, etc. This is the first one, okay, when we talk about model parameters. And also here model parameters, they don't work very much work on target, or they don't work on target or predictor variables by a lot. But hyperparameters, they solely depend on how the algorithm works when it is kind of learning from the data. Every algorithm has its own set of hyperparameters. For example, we were just discussing about the decision trees, how we have n sample, or probably minimum depth, maximum depth, and all. So these are all hyperparameters. Okay, hyperparameter is given to us by default, and they would work as long as you use an algorithm. Okay, but when we talk about model tuning, or when we talk about like hyperparameter tuning and model tuning, right? So when we talk about model tuning, here we have things which are moreover look into training, testing, and validation. Right, guys. So here we have a lot of methods. The first one is you have regularizing linear methods, wherein we would be calculating the shrinkage. Okay, or you have shrinkage methods. For example, when we have a lot of parameters, and there are some parameters which are not necessary, and you might want to check the dimensionality, then we can use PCA. Okay, and here when you use PC, it would give us the the magnitude of eigenvalues. And this method, it kind of reduces the coefficients, and the result that you have is very simple. So you have two shrinkage methods, right guys? The first one is ridge regression. Ridge regression is pretty closely related to linear regression. Okay, here in ridge regression we use sum of squares, right guys? But then here in like whenever you are coming across, or whenever we come across this, why would we have to use the shrinkage function, or why would we try to shrink the coefficients? Like what would that do for us? Now when you do this, it would basically ensure that it is not overfitting, and also that it would not be liable to variance errors, right guys? So you, if you make a unit change in input variable, the change in magnitude also would be very large if not for that. So here when we talk about shrinkage of coefficients, they are basically done to ensure that your model is generalized, and also that your model has less number of errors, right? Then just like ridge regression, we have another which is lasso regression. But in lasso, we would use another new word which is called penalty term. Right guys, now all these, they are different kinds of model parameters and hyperparameters that we're talking about. Okay, so here the next one that we have is lasso. Now when we talk about lasso, it's pretty much similar to ridge only, except for the word penalty as discussed. And guys, lasso is also called as L1 normalization. Alright, just in case if you are listening to this word for the first time, then lasso is called as L1 normalization. So as the input parameter, the term as the input parameter keeps coming, if the value is very high, then we would try to shrink the value more. But in ridge regression, the coefficients are generally moved towards 0, which cannot happen in lasso, because in lasso we have something called as penalty, right? So this is what we mean by both of them. Now talking about hyperparameters and tuning and how they work, let us now understand a bit about it. So hyperparameters, they basically control the behavior of algorithm, right guys? So as you can see, or as you can understand, hyperparameters, they control the behavior of algorithm, and also they are kind of given through arguments. When we talk about hyperparameters, like we would not directly use a hyperparameter without any use. So for example, if I don't use decision tree, then I would not be able to use minimum sample split. Right now when I say without use, obviously there is nothing in coding which we would be writing without use. Most of the times, sometimes that might be a human error. But if I want to use minimum sample split equal to 3, I can't use this on some random line just because I have random forest, and within random forest I want decision trees. No, that's not how we would be able to do it, and that's not the way to do it either. So that is why we would be using something like RF. Here is random forest, but if you use random forest, you would not be able to use the hyperparameters of decision tree. So that's how it works, right guys? Now these hyperparameters are passed into arguments. Now after all these are done, okay, and you use the function that is get params or something to see how your function is working, here you could give different parameters also. Now this leads us to the next topic, that is how would you fine tune your parameters. Now to fine tune your parameters, that is why we have different features in regression and classification. You could look for parameter space. You could probably try resampling your parameter space. You could use cross validation schema, or you could also check the score directly. Now, when we talk about the second option, okay, let us just make a list of all what we have. We are already done with understanding what is regression and classification, right? So, no much talks about them. The second one is parameter space. The next one is sampling. Post sampling, I have cross validation, right? Then I have score check. These are the different features that I could use. Now, here, when we talk about which of these, where, why, and how we use, then let us just understand that grid search is not used in all the cases, right, guys? Grid search is generally used, when you would want to find out parameters of a lot of values, right? So that is where grid search comes into picture. So here when we talk about grid search CSV, we have to know that in grid search, we would be using a couple of parameters wherein it would go and check through all the uh, properties or all the options that we have specified here. Right, guys? That is what we mean by grid search CSV. Right. So now, anyways, going forward, how does grid search CSV work, or what does grid search CSV look like, or let's just talk a bit about grid search CSV in specific. Now, as I said, grid search CSV is not used each and every time. Now, why is that? The most important reason, or the most important uh, technical drawback that we have is it takes all the parameters combination. So grid search is grid search CV. Otherwise, it is grid CSV, which is grid search. Okay. So here it is basically a parametric combination. Parametric combination. But just like grid search, there is also something called as random search CSV. Sorry, random search CV. When we talk about random search CV, it can, kind of sample a number of, possibilities with, uh, distribution of parameter space. Okay, so this is a combination, while this is a sample of some or certain distribution. And guys, now when you are tuning your hyperparameters, the data should always be divided into three parts here, wherein it's training, testing, and validation. Okay, and the same features or the same functions, they would be used to transform the test data wherever you would want to do it. All right. So now just to summarize everything about grid search, it is basically a hyperparameter tuning method as understood and as written. It is computationally expensive. Yes. It uses almost all the values within it. Yes, that is what we mean by parametric combination. It is the best model performing value or parameter that we have. Well, I would say yes to that also. For each permutation here, cross validation is used. Okay, and the scores are calculated. That's another feature about it. And every model that is built, it would be validated and ranked. That is the second part of grid search. And well, not to be surprised again, grid search is very healthily a part of sklearn library. Right, guys? So we would be using grid search CV from sklearn. Now that we've discussed so much about grid search, there is one thing that is directly in connection to grid search, which is randomized search. So now we'll talk a bit about it as well. Randomized search CV. Now this is a bit different, or this is not very different also. This is just a bit different as compared to grid search. Here we would be having statistical distribution. That's it. I mean, the biggest difference. Statistical distribution. Now, from the combined values of different parameters we have, randomized search would randomly pick values. It would at randomly pick values. Okay. Now, the reason that we use this kind of thing instead of grid search is because here you have a lot of hyperparameters, or you might have a lot of values which are not important also. You might have some which are very important also. So you could understand that trend, or things like those when you use randomized search. And here not every combination is evaluated with respect to grid search CSV. There are no, there are, I mean, the fixed number of parameter settings is selected from the kind of distribution. Okay, so in short, random search has better chances of getting correct combination than grid search also. Okay, now in a lot of cases, you might have to work wherein you would want to tag the different processes that are done, and here you could use something called as pipeline. Pipeline is also a part of sklearn only. Pipeline is something like coming up with different algorithms all in one, or probably different types of algorithms all in one line. Okay, so pipe is a class firstly. It's not a library, guys. Pipeline. Now this is basically to ensure that you build only one line, or probably only one process which consists of different processes. Okay, the same condition is called as piping in our language. Okay, so pipeline when used with grid search CSV, it will give you, or it will find out all the hyperparameters at every stage. Right, guys? So this is one advantage of using a pipeline. And that brings us to the next part, that is how is a model, oops, how does a model work? So here, as you can see, I would first be understanding my data or gathering my data, then I would be building understanding my data after I get my data, after which I would be building a model. And when I build a model, I would be feeding my model with different data or different algorithms or whatever, and then I would validate the process. And this process, it just keeps repeating. And guys, so I hope each and every one that this easy part, or what I'm trying to tell you here, is very easily understood. And if not, you all know what to do. Please write down to us, and we would try to get back to you at the earliest with a solution. Right, anyways, going back to where we started it from. So here I have a small code for us, which is SVM loan prediction. And basically here we are using, so from sklearn model selection, I would be using grid search. Right, guys, and when I use grid search, these are the different parameters I would be entering. Anyways, let us not jump into a conclusion. Let us go back to the code and understand what we're doing here. So as you can see, this is a code that we have already worked on, but we are just taking this a bit more detail. We are not stopping this with accuracy, or probably we are not laying stress on accuracy moreover right now. We are laying stress on other features. right? And that is exactly what we're trying to cover now. So as you can see here, I have two data sets, one for my test and one for my train. I want to print the values. So there is my in train input and my test input. Now when I try to print these values, I'm printing only the columns. So these are the different columns we have on the train, and these are the different columns we have on the test. So as you can see, the only difference between train and test is I don't have a loan status probably in my test. Let us just take a minute to check just to be sure once again. All right. So I think now you have also got a comparison and you have been able to see that these are the only two. Uh, I mean, within these two batches, the only difference is loan status. Rest all I see are common between both of them. We have almost everything. So now what we would be doing is I would be using concat. Concat is concatenation, and concatenation would merge or it would club two tables or two data frames or something like that. Okay, so done that. So here I have, if you can see now, I have my 981 rows followed by 13 columns. It was earlier 12. Okay, now done that. So these are the list, or this is the list of different set of values that we have. Right, guys. So now, notwithstanding this, as we keep going further, I would want to check the number of null values that I have within my data set. And here we have a list of null values on the right hand side, right? Then we would be looking at counter, wherein when I do the counter step, we would be having a count of how many males or how many null values or how many options we have within each of them. So here I have 775 male, 182 female, and also 24 values which belong to null. They've not been marked properly. So in this case, because we have only two options and there is no mathematics, what would be the value that you would be inserting in NaN? Guys, I would recommend that you put the video on pause for a second, think about the answer, probably make a note of it, and then compare how and what is it that we would be doing to ensure this step doesn't repeat there, right? And in order to do that, what I would be doing now is I would be seeing, or I'm noticing that I have 775 male and 182 female only, right, guys? So I think 700 plus 100 is almost 800. Okay, 82 plus 20 is 900, and okay, we have around 1000 females, sorry, around 1000, which is the population. Out of 1000 I have 77% which is males and 18% which is females. Now in this case, guys, I might probably push all the values into male only. Well, this has got nothing to do with gender discrimination. The only thing is the count, because we have a volume of 75 to 80% which are all into male only. Even if I have mistakes that get passed into male, the chances of having mistake would be very low, right, guys? So now done that. So here are a list of all the null values that I have. I have a null value in 23rd, 126, 171. So these are the different null values that I have. Then this is my gender, which is the column. So I would be using values to convert all of them into male. So here it goes. All that is done. And this process of data cleaning, it keeps going on and on for a good number of steps. So after handling the gender, the next step we would be handling is married. And I would be filling all the values of married with a yes, because we have majority of the people who are married. So if you can see here, we have married, uh, yes or no, and this is for dependents, yes or no, right? So dependents, false or true would be talking about it. Married, false and true would be coming here, right guys? So these are the different values that we have. So here I see that there are only three values wherein the marriage is not entered. So I would be pushing this into yes. And now let us check let us check how many married. So we see that it's resolved. Earlier we had three. So this problem is solved. Right. The same step is something that I am now applying for my dependents, wherein I would want to see how many people have how many dependents. That is 545 people have zero dependents. There's 160 people who have one dependent each. And it goes likewise. Then I'm using a cross tab, and this time I'm checking, I'm using a cross tab for all the married and dependent values. Okay, so this is dependent and this is married, and here goes my cross tab. Done that. In my next step, I'm again checking dependents and married, this time a bit different. So these are the people who have zero dependents and are not married. These are the people who have 3 plus dependents, like we have 79 people who have dependents of 3 plus and they are married. And guys, so this is how we do or we work here. Now going forward, again I'm using my dependents, checking my dependents basically. I still have 25 people who are unanswered or where there is null values. So we would again change the values. We would see, we would check. So these are all the values that we have. And here you go. Now when I check for gender and dependents, you can see how I have all values which are populated. Now when I check the values of dependents, now let us come to dependents, we see that we have only 10, right? So now let us go to the next step wherein I am checking the loan amount. So this here is my loan amount, and these are the terms like 6, 12, 36, 60. So this is for months, 60 is 5 months. This is 60 is 5 years. This is 3 years. This is 1 year. So you have different kinds of loans that you could probably take based on different types of loan amount or loan amount term. All right. Then these are the values that we would be checking for use for loan amount 2. Then I would be checking the loan amount term followed by the value count. After which here, as you can see, we are using the loan amount term, and I'm using loan amount term, and I'm giving all these to be null values. Like wherever it is, then it should get populated with 360. Okay, and then I would be checking the credit history value count. So these are the people with 1 is good, people with good credit history, and 0 is people with bad credit history. So 1, I have 754, I have people with good credit history, and 148 people with a horrible credit history. Then we have cross tabs, and in cross tab I'm using credit history of 0 and 1, and we're using gender too. So you can see that we have 611 male who have great credit history. We have 30 female who do not have good credit history. Right? Then going forward, self-employed and credit history. So now we are trying to check the relationship between both of them. So here I see that there are 125 people who are not self-employed and who have a horrible credit history. The same applies here. Now in my next step, we would be using, okay, not logistic regression, not so soon. So here I'm using my loan status null and I'm passing my loan status into it, checking all the place where I have my values and then I'm populating them with Y. After which I would have to check the columns and then I would drop the columns, unnecessary columns. And here I would be having a neat and a very elaborated table. Again, coming back to check and I see all my values are now 0 except for credit history. Now that it's all clean, I would split the data into test and training. Okay, and we all know why we split the data into test and train. We know how it makes our data better, or probably how it makes the algorithm better. Test and train. Test is the part of your data set which we use to train the algorithm on, and then when we move on to the test model, test is again a model which is used to cross evaluate or cross check or see the model performance. That is where we would be using the other. Right, so here now you can see we have 846 comma 15. So why 15? It is because we have dependent columns up to dependent 3. So almost all these columns, which we are talking about, they are all very important. Okay, and why do we have 15 is because earlier dependence was only one column, but now dependent 1, dependent 2 and dependent 3. And now what we would do is, because we have too much of information, I would remove a few columns, and I would remove columns using my most favorite condition. And when we use this condition, your values would be taken care of while processing only. That is get dummies. So now as we keep going further, here I'm using logistic regression to check the model. So these are some values. Then I'm again using concatenate and I'm using all df is my data frame. I'm checking the shape, it is 925 again, 925 comma 15. And now I'm again checking my values. After checking my values, I'm seeing if there are any null values available. Now there are no null values. Now I would split the data into test and train, and then I would be applying SVM finally. Now comes the fun part. Now when I'm working on SVM, right, SVM has SVR and SVC, that is support vector classifier and support vector regression. But as we all know, SVM is mostly used for classification only. So here I will be using SVC, fit the model, X train, Y train, and then we would be using prediction, after which I'm using a very simple metric just to see how it is performing, which is accuracy. And within accuracy, I see this is my accuracy, and because this cannot be it, this is not how it is done, so I would be using something always based on accuracy. And when you use an accuracy of this sort, right, or an accuracy wherein you want to check the baseline or something like that, in that case you cannot have the others to be 0.
That is something which won't happen. And that is the reason why we would be using, or we have an accuracy of 76. And in order to avoid this, I would now be using my baseline accuracy to float. And this is 77 only, not much of a difference. Now, because this is not keeping me happy, I would now try something called as grid search CSV, right? So here, when I be using grid search CSV, you can see I have grid values like C has two values, gamma has three, and kernel we would only be using one. Now here, the best part is you can enter different values of C and gamma. And what your model would be doing is, as you can see here, it would first check for 0.01 followed by 1 and linear. Then it would check for 0.001, 0.08 and then linear. And then again back to 0.001, 0.09 and linear. Again, after this, it would go to 0.011 linear, 0.01, 0.08 linear. So it would check for all the possible combinations. That is exactly what we have discussed earlier too. Right, guys? I hope now you have been, or now you are able to link back to what I'm trying to tell you. So here I'm using my fit wherein I'm fitting each of these models to it. So I have my gamma is equal to 0.08, then you see my gamma is equal to 0.09, and then here C is 0.001, then 0.01, then my gamma is 1, then my kernel is linear. So it would try and check for all the different values that you have provided, and once it would have checked, it would, or probably you can use something called as get parents or best parents. And when you do best parents here, you would be able to see what are the best values that you could use. All right, I'm keeping this in mind. There is also something called as grid best estimator. And when we talk about best estimator, it would give us those values which are getting populated here. Right, guys. So this is the best estimation that your support vector classifier can give you, and this is the best. And this part here, this gives us the best parameters that you have within grid search CSV or grid search CV. Right, guys. So now again, let's go back to the slide. And these are some very important libraries that we have, notwithstanding what we just saw. You have Raytune, you have Optuna, you have HyperOpt, Bayesian optimization, gPyplot, Scikit optimize. So there's a lot that you could use. Right, so I really hope that you have understood what is the difference between model tuning and uh, hyperparameter tuning. Right, so the difference between each of I mean the understanding the difference between each of them is very important, and that's exactly what we did in today's session. And then we saw what is grid search CSV, and this we did using SVM algorithm. Right, guys. So I hope what we have covered is understood and that you have also enjoyed the session. Thanks a lot for your patience. Thanks a lot for being around. And also thank you very much for listening to me all the while. And if you found that this video is of any use to you and probably it might have enhanced your skill a bit, then please do not forget to hit the like button. And also, do not forget the subscribe button followed by the bell icon, because when you do this, you will be having access to a plethora of videos to watch and also a great number of technologies to choose from, right? So yeah, and you wouldn't want to miss a video when we come up with a video, or when we update a video online. So to ensure all these don't happen, please like the video to motivate us and subscribe to the channel to stay updated. Thank you very much. This is me, Varun, your trainer, your mentor, signing off, wishing you all the best for all your future endeavors. Thank you very much.